Hi, good afternoon. Are you enjoying Okinawa? Yay! Okay, today I'm going to introduce my product, an mruby for WebAssembly. I'm going to introduce myself first. I am Uchio KONDO from Fukuoka. I work at Mirative as an infra engineer. Mirative is one of the largest live streaming and live gaming app in Japan. Also, I am a translator of learning eBPF. Now, learning eBPF is available in Japan. So, please tell me your console. Please mention me if you read it. So today I'm going to talk about Ruby and WebAssembly. But first of all, I will present a lot of kinds of language examples. So I changed the background for the watcher's convenience. This slide is multilingual. So please be careful. Okay, Ruby for WebAssembly. What I think you already know about Ruby.wasm. It is a C that is compiled into WASM binary. You know C is C language based. Then you can compile it into WASM format. You can run it on browsers. But I'm going to show another approach. It is mruby Edge. mruby Edge is basically mruby, but specialized for WebAssembly use case, right? So what is this? mruby Edge consists of two components. One is core crate of mruby Edge, and the other one is make command. And you can install make using cargo command. Okay, can you understand? I think you can understand this plain old Ruby script that calculates Fibonacci number. Okay, and also you have to prepare RBS file for this fib method, like this. If you have these two files, you can compile it into one WASM file. This WASM file is exporting the function named fib, and you can check it with WASM object dump command. Then you can run this using some runtimes, for example, WASM Edge, and so on. This calculated Fibonacci number may be correct, right? So I think you doubt, can this WASM file run on browser? The answer is yes. You also have to prepare this kind of WASM HTML, including this WebAssembly JavaScript code. Here, this is a working demo of that fib WASM. So when we put this and then calculate it, the fib 20th Fibonacci number. And this is not the mock code. Here is a 22nd Fibonacci number. Okay. So mruby, you can use mruby Edge both on server side and browser as one WASM binary. This can export specific function, and in addition, we can specify functions to import for that WASM file. Okay, this is the mruby Edge, but before we understand this, we have to have a grasp with two technologies. One is WebAssembly, and one is mruby. So let's start the journey together. Vamos. Okay, first tour is about WebAssembly. But how do you know about WebAssembly? I think it's browser-based something magical. Or as I heard that Ruby or Python or Lua or everything can run on browser using magical technology. Or also, I think you have heard about that. Google Meet uses WASM to especially encode images or video, or you can play games on browser using Unity 3D as a WASM compiler. Okay, so WASM is almost everywhere. In technological view, WebAssembly is a stack-based virtual machine that can run its instructions on browser or on server with everything. So it is used on browsers, server-side programs, configurations such as load balancers or log aggregators, or even containers, or even supervisors. So, for example, Envoy is very high cloud-native load balancer solutions, and it uses it can use WASM as a configuration DSL, or FluentBit, or Open Policy Agent. Cloud-native technology use WASM as a configuration binary. As we have seen, one WASM binary can be executed both browser and terminal and return the same result. And now that you know, WASM can export functions to outer world or import functions from outer world. And this is the interface, basic interface of WebAssembly. So mruby Edge supports this kind of import and export. This is runit Ruby. This uses show answer method internally. You can specify export.rbs to export what kind of method and its signature. Specify import rbs to what kind of function to import with signature. Then compiling a WASM file, you can use this in browser as using import object. The result is maybe 21 plus 42 and show 63. All right. This is the basic of WebAssembly. Let's go into one more step. So WebAssembly is basically binary with layout information, magic number, version information, and a lot of sections. Sections are now 12 kind of sections. For example, type, function for function declaration, or memory or global declarations, or export input functions, or bodies of functions, or its data. You can inspect WASM code as a assembly format called WAT. And also, you can check the exported function signature like, using WASM object dump. You can check function section and type section. Now, combine it with, when we combine both information, we can check if the field function has I32 to I32 signature. Yes. This is import and export spec. Also, we must understand a basic of WASI. Yeah, WASI is an interface to system functionalities. For example, when you want to access files, sockets, randomness, or raising thread, or getting clock time using WASM, you can get these information via WASI. Also, so WASI is basically bunch of functions to import. This is a compiled WASM file using Rust C compiler, and it automatically specifies the import of WASI functions. They are very similar to system codes. Such example is that WASI's FD write function is very similar to system called write. Random get is like get random, and so on. So WASI is basically the bunch of import functions. So you can generally easily stub these functions. For example, there is a browser WASI same project that stubs almost all of WASI functions. You can specify the WASI import on instantiate the WASM. The code is basically simple. For example, browser WASI same implements clock get time WASI interface as a function using browser state class. For example, random is also a WASI feature. This is a very simple Ruby's code using random. This specifies the import of random get. When you want to use this on browser, specify random get. You can implement random get by yourself as using math random in browser, and then put it into import object 10 times get random. The result is at random, right? So, but this randomness is from browser's math random. All right, this is also for now. I think you understand basic of WASM and WASI. So next tour is about mruby and its PM. So but you have two questions maybe. what is mruby and what is VM? So at first, I'm going to describe about VMs. You know, some languages has its VM, Java, Erlang, B, or Python, or Lua. Okay, also Ruby had its VM called YARB since Ruby version 1.9, 1.19, sorry. 1.9, sorry. This is how Ruby works. Picture. When you pass Ruby script into a Ruby binary, the Lexer works it into chopped tokens, and the parser working it out into AST3, and the compiler makes this into a 3-byte code, and then YARB evaluates the byte code, and the program works. How to check the Ruby instruction set is using easy way is using dump options. And this is compiled instructions, and basically it's not so hard to read these instructions. And note that the instructions are stack based, so the put object puts 1 or 2 into stack, and opt plus execute plus over 1 and 2 on stack. So so now you have understood about the Ruby's basic, but how is mruby? Yeah, and this is a basic description of mruby. mruby is one of Ruby implementations by Matt himself. It has a features of it has some features. For example, it has register-based VM, smaller footprint, composable runtime libraries. And also, mruby has its VM and its execution path. The one big difference is mruby can evaluate the bytecode file itself directly. And the bytecode file is called mruby file. Also, mruby can easily dump its instructions. This looks a bit different from Ruby's one. Also, let's compare it with Lua. Lua also has register-based VM, and you can compare it into instructions. And it's like this. mruby's bytecode is similar to Lua rather than Ruby's. Okay. The difference is VM architecture. Ruby's stack-based and mruby's register-based. mruby's bytecode is, I think, more portable. You can mruby's basic functionalities is one of mruby's basic functionalities is to make a direct bytecode file. You can port it other runtimes. So using VM has a lot of merits, but today I'm going to focus on cross runtime portability. So I should introduce new runtime of mruby. Do you know mruby-C? It is yet another mruby for microcontrollers. It has a bit smaller footprint than mruby. It is for limited environments such as ROS. But mruby can handle mruby's bytecode too. When you compile the mrubc command, use this sample scheduler command is just corresponding to mruby binary, and you in advance prepare the test.mruby using mrubc, and you can pass this into that mrubc command. The result is shown. Okay, so mruby's bytecode file can be used for mrubc. Picoruby uses mrubc, so the keyboards can be used with mruby VM. So note, remember the name of mruby edge. So you can imagine from this name that the mruby edge also accepts mruby bytecode. That's right. So I'm going to the implementation. So for now, I have described about mruby edge's architecture. The good point is mruby edge has two good points. One is binary size. So Ruby wasm with all dependencies makes 18 megabytes wasm binary without about 8 megabytes. It is small enough, I think, but fibwasm, I create fibwasm using mruby edge, and it has just 174 kilobytes, but it omits basic features of mruby, just calculating Fibonacci number. So also, as you have seen, mruby edge has a first-class support of function import and export. So mruby edge has a strong point to RubyWasm, but my core motivation is my desire to implement my own VM. But it has lots of unsafe code. The architecture is very simple. In make command, we compile Ruby script into mruby bytecode. Actually, it uses mRBC. Also, I created mruby compatible VM using Rust, and then combine two parts into one WASM executable. And this one binary WASM can run on both browser and WASM runtime. Okay, and this mruby edge has support to import and export function, but importing and exporting you require type signature. So we must specify RBS file for declaring the types. And this is a new use case of RBS, I think. So mruby edge has naming conventions. When you want to compile file.rb, you must prepare both file export RBS or prepare import file.import RBS. Yeah. Also, I want to talk about some hacks handling strings. It is something to be Before that, we must understand what the memory model, basic memory model. What the instance has linear memory, and the WASM is basically isolated from host environment memory. So when we want to share data between host environment and WASM instance, we should use this linear memory to share data. Okay, what we call string is just a byte array on WASM linear memory. For example, this hello string it has offset 1024 and length 6. And you can specify this string using offset and its length. So when you want to pass string from browser to WASM, you must copy bytes one by one into WASM linear memory. This is sample code of JavaScript. This for loop putting the string into the memory buffer. After that, you can call this using I just put method. Internally, this use string I just put method accepts pointer and length, and then you can instantiate the string. Okay, the reverse pattern is vice versa. So mruby has its string handle conventions. When you specify RBS in RBS, that the argument is string, this is converted into pointer and length. Also, you can specify string that is return value. It will become a pointer. Also, it exports get buffer size automatically to getting buffer size. When you want to use import functions using string, the string type will be converted pointer, offset, and length. So this is the export example and import example. So imported function accepts offset and length. You must extract the memory buffer, then convert this byte array to string in browser. So this is so complicated. So I expect WASM complete model to solve this. The API supports string. This will be better specification. I hope better generators will appear. Right. So for your information, this is a new WASM interface type format. And finally, I want to talk about evaluation using Fibonacci. This is bench code of Fibonacci. This is the result of mruby that run on browser. But also, we can run Ruby WASM on using Fibonacci. This is the result. This is comparison JavaScript result. So basically, mruby is about 80 to 100 times slower, lots of room for growth. I'm very relieved that is 1,000 times slower. Okay, so I use WASM Edge for server-side benchmark. This is the result. This is all basically 10 times slower, but mruby Edge is faster on Bootstrap because there's almost no loading process. WASM Edge invokes 2000 milliseconds, but Ruby WASM requires about 7 seconds. And I have an internal bench step by step, and the result is just here. Sorry, I'm going to hurry up. So wrap up, we have learned about WebAssembly and mruby. And mruby Edge is a combination of these technologies. It's still actively developed, so a lot of works to implement. But mruby Edge is basically smaller footprints, so it will help you to embed your Ruby code using WASM plugins. So thank you.